All right. Again, the big deal is, obviously, as I was just informed, that the a bookstore is having to back order some stuff. That's just brilliant. But the fact of the matter is, you can't order this stuff online. And so when you go over here to your website, I've even actually put it on here. You've got the 24/7 live chat. You can go right here and talk to Hawk. I also put there a 1-800 number here because I don't like chatting with the computer. I like calling somebody actually on the phone because I'm like old school. So whatever you want to do, but if you don't have it, you can go and order that stuff because even when you go into the Hawk system here, you can create a new class, create a new account, and when you create a new account, they even give you, I want to purchase the access code and stuff. But I want you guys to call them up first because I want to make sure when you purchase your stuff, you're not just going to get the access code in the ebook, but you're also going to get the guided notes that we give you guys, our little notebook that we're working with and stuff like that. So make sure you get that with them. So, and you should be able to get your access code immediately with that. They may have to send you the notes and stuff. So there you go. So like I said, when you come over here and get yourself into the system, it looks like this, and then I'm going to go to, there's my course. Actually, let me just show you what I do. I go into the learning system, I type in my email address, and I've set myself up a password, and I log myself in. And if you guys had college algebra, which I think most of you guys told me you did, you may see several of your textbooks down here and stuff like that. I also taught the college algebra and stuff. And then you can go into view the course. And right in here, I'm viewing the course, and this is what we did last time, lines and their graphs. This one, I'm doing section 1.6A here today, the introduction into functions. And again, we have, within the learn mode, you can go and start this thing. They also have their embedded videos in this thing where some of the stuff that we're doing that connects to the learn mode is in there. So I want to kind of point that out. But most important, after I do the notes and after we go through the examples and stuff, what I really would like you to do is go and practice a little bit because the practice, there's no, these are not points, it's just kind of showing you the kind of problems, but the goal is to certify. And on this one, our goal is pretty much to get you guys at 80%, but depending on the number of questions, 80%, you're supposed to get how many right versus how many can you possibly miss. So mastery on this level would be 77%, because that's about as close to 80 as we can get you there. And then we can actually just do some problems and stuff. So let's go ahead and get started on this particular section. This is dealing with functions. Now, I know that this chapter 1 stuff, please, I know you've seen all this stuff before because it's kind of a requirement for your college algebra or your pre-calculus class, and that's normal. Chapter 1 is review. Chapter 2 is where we're going to really get into the calculus, but we have a lot of different folks in here with a lot of different backgrounds, so I just want to make sure that you're comfortable with this stuff, and it's always nice to start out with a good A on everything. So this one's dealing with functions, okay? And the goal here is obviously to evaluate functions, to work on the domain and range, and figure out when we actually have a function and we focus on something called the vertical line test. So under that learn mode, so if you go back over here and go under, here's my little page on section 1.6, under the learn mode and stuff like that, on the little video, they're going to talk about these particular problems up here. Okay, but because, and I want you guys to do this on your own. So this is the kind of stuff you're actually supposed to do before you come to class and get the learn section already set up for you guys. This is the ultimate goal of the class, is kind of get you guys to do a preemptive start and go ahead and watch the little learn video and get yourself acclimated to the section before we actually do some of the problems in class. Okay, that's the goal. But I know that several folks are having some difficulty getting their access code because our bookstore ran out. So not a problem. I'll do these guys for you guys, but after a while, I'm not going to do these anymore. All right. So on their awesome video, they're going to sit there and talk about, well, the idea here is let D and R, and that typically means domain and range because we're math people. We just have to come up with obvious letters here. Let D and R be two sets of real numbers. A function is a rule that matches each number x in the D, which is the domain, with what, blank, blank, number y or f of x in the R, which is the range. Well, here's the deal. Now, the key to it is a function will match exactly one x for one y. Okay, you can have the same y. There's no restrictions on what y has to be, but the answer is exactly 1. For any x I give you, there can only be one y that matches to it. If you got more than one y, that's not a function. Okay? 2. X is the blank variable of the function, and y is the blank variable of the function. Typically, we're talking about this input-output situation here, and with the input, you plug in x and you crank out y. Plugging in x is called the independent variable. Okay? X is the independent variable, and y is the dependent variable. Okay? And as I kind of gave away the hint up here, what do you think D is called? You use D for a main reason here. D is the domain, of course, and R is called the range. And what you need to think of, let me just put it in you, again, remind you of your college algebra days here. The domain are the set of x values to get all the set of x values of a particular function. The range is the set of all the y values of the function. So you input the domain and you output the range. So it's kind of a grouping of all the x's and a grouping of all the y's is what the domain and range is. Okay? A single function, okay, that is represented by different algebraic expressions to be used for different parts of the domain is defined as what? Let me give you an example of one. What we're talking about here is this. Something like f of x is equal to 3x squared plus x minus 2 if x is less than or equal to 1, and 4x minus 5 if x is greater than 1. This is the type of what they're talking about. A single function represented by different algebraic expressions. Well, you remember the name of this type of function? You got it, piecewise. This is what we call a piecewise function. Okay? And then, last but not least on this stuff, the vertical line test states that any vertical line intersects a graph at more than one point, then the graph is blank blank represents a function. Okay? Okay, got a little fill in the blank here. But what you guys remember about the vertical line test here is this. If I happen to have a graph of what we call a relation, anything, so something like this guy here. You guys remember what this guy's name is? This guy's a parabola, okay, an x squared kind of a graph. Or maybe over here, I could do maybe a circle, okay? The vertical line test tells you when you have a function and when you don't. You take any vertical line, okay, you put that vertical line anywhere on the graph. Multiple vertical lines. When you look at any vertical line individually, how many times does it intersect the function? Or intersect the graph, as it will. How many times? At most once. If it intersects at most once, this is a function. Okay? However, do you see the circle over there? When I draw a vertical line, how many times does it intersect? In this case, twice, but aka more than once. So when a vertical line intersects a graph more than once, the graph is not a function. So the answer for this one, then the graph does not represent a function. If you graph it more, if a vertical line hits more than one point, it's not going to be a function. And that's the kind of nice thing you can tell. You can look at a graph of something rather than you can look at it and just in your mind imagine a vertical line. If it intersects the graph more than once, it's not a function. Now, also under that learn mode, they have quote unquote Hawks TV, where they had some poor professor sit there and actually do a couple of problems for you guys. And we also want you to watch these Hawks TV. This is the before thing. This is what you're supposed to do before you come to class. You already know what sections, based upon my interesting pacing guide here, you know what sections I'm going to cover. So I want you guys to go in there and hit the learn mode before you come to class and just review it, get those little parts of the notes on that learn mode, and watch the little Hawks TV and do make sure you can do these particular problems. Now, again, I know you guys, some of you guys haven't got your access code yet, so we'll just work through this thing. F of x is equal to 3x squared minus x plus 2, classic function. Now, I know you've seen this stuff before, but we're warming you guys up. We're about to do calculus in here. And with calculus, we use a lot of that algebraic notation. So we want to make sure you guys are very good with this algebraic notation before we slap you over the head with calculus stuff, okay? So, if f of x is equal to 3x squared minus x plus 2, then what would f of negative 3 be? Well, the whole goal behind this functional notation is, I don't care what's inside the parentheses that comes after the f, that's what I'm going to replace the x with. So in this case, this would be equal to f of negative 3 would be 3 times negative 3 squared minus negative 3 plus 2. Now again, what I want to show you here is literally I am replacing all the x with negative 3. Now you've got to crunch this thing out. And where most people are going to screw this up is crunching it out. It's not the algebra, it's the basic arithmetic skills that kill students. So, order of operations, what do you do first? Let me go through that as order of operations. What's the first thing? Inside parentheses. Second thing, exponents. Third thing, multiplication, division from left to right. And the last thing is adding or subtracting from left to right. This is how we do mathematics. So, okay, I see inside the parentheses, but I just got basic numbers inside the parentheses. So the next thing is going to be exponents. I got one exponent, negative 3 squared. What is negative 3 squared? Positive 9, because negative 3 squared means negative 3 times negative 3, which is positive 9. So this is 3 times 9. Let's go ahead and clean up some more stuff. A minus minus makes it a what? Plus 3 plus 2. And then I'm going to do my multiplication. 3 times 9 is 27, plus 3 plus 2, and 27 plus 3 is 30, plus 2 is 32, according to my math. Does that make sense? And the reason why I'm showing you this is this. It's that darn calculator. Because how many times have I had, Dr. Taylor, I think you're wrong. According to my calculator, negative 3 squared is negative 9. Well, let me show you. And this is what they type in. They type in negative 3 squared. Problem is, you're right, it gets negative 9. That's because the calculator is doing order of operations. The negative 3 is not inside the parentheses. So if you look at this, it's only the 3 that's being squared, and then you negate it. And the multiplication times negative 1 aspect comes second. So 3 squared is 9 and negative 9. What you really want is the parentheses, negative 3 20 squared. That's what we were doing, and that really is 9. But people do this thing so quickly on their calculator because they're not thinking, they're just pushing buttons, and then all of a sudden they screw up with the wrong answer because you got to make sure you program the calculator just right. All right, f of 2, you got it, plug in 2. So this would be 3 times 2 squared minus 2 plus 2. That'll be 3. 2 squared is times 4 minus 2 plus 2. That pretty much cancels, and 3 times 4 is 12. So, no major problem here. Somehow, because I'm trying to show you that as basic stuff as is, math is not designed to be hard. And the way we try to explain it to folks is try to catch a pattern on this stuff. So, right here is where people die. Right there. And this is going to be, you're going to see this one a lot in calculus. Calculating this f of x plus h. Well, f of x equals 3x squared minus x plus 2. What is f of x plus h? I don't care what's inside this parentheses. Whatever's inside the parentheses is what I replace the x with. And then we'll clean them up. So officially, this is going to be 3 times x plus h squared minus x plus h plus 2. All I did here was took every x and replaced where there was an x, put a parentheses around it, and put x plus h. And we're squaring it minus parentheses x plus h plus 2. And that's my answer, but that's not going to be good enough for us. We're going to want you guys to clean this stuff up, okay? So, order of operations inside the parentheses, they're already tight and cleaned up, x plus h's. Next order of operation is squaring. Squaring means multiply by himself. So that'd be 3 times x plus h times x plus h minus x plus h plus 2. And multiplication comes next. And how do I multiply x plus h times x plus h? What am I going to do? Distribute, and the famous word is called FOIL for that, first, outer, inner, last, but it's the FOIL method. You're going to distribute this thing through, leaving the 3 out front, x times x is x squared, x times h is plus xh plus h times x, which is another xh plus, and plus h times h, which is plus h squared. And here I'm going to distribute the negative. That becomes minus x minus h plus 2. And combine like terms inside the parentheses. So this is 3 times x squared. xh plus xh. How many xh's do you have? That would be 2xh plus h squared minus x minus h plus 2. And then the last thing I'm going to do is distribute the 3. And that's going to give me 3x squared plus 6xh plus 3h squared minus x minus h plus 2. And this is the extended version of the answer. Both these two answers are exactly the same, but this, quote unquote, has been cleaned up. Because this is the type of algebra we're going to be doing when we get to calculus, so make sure you can do this particular procedure. Okay? Now, and remember, most important, where most people die with this stuff is right from the beginning. When they see f of x plus h there, it's f, pause, parentheses, x plus h. I'm plugging x plus h in for replacing the x in the original function. I've seen students, mostly the mistake is they do this. They write down 3x squared minus x plus 2 plus h, and they chuck an h on the end of it. That's not f of x plus h is different from f of x plus h. And this is the English idea of that. Pauses is basically where I'm trying to tell you where the parentheses are at and stuff. The h is inside the parentheses, so it's got to go over there where the x's are with. All right. So here's our practice, and this is the practice getting you guys ready for certification here. So these are the kind of problems you can anticipate on the certification. So given f of x equals 1 minus 2x squared, what's f of 9? Well, here we go. This will be equal to 1 minus 2 times 9 squared. That'll be 1 minus 2 times order of operation. 9 squared is 81. So this will be equal to 1 minus, and 2 times 81 is what? 162. I can do that kind of math out of calculator. 162. And 1 minus 162 is a negative 161. Does that make sense? Next one is, what is f of negative 5? We'll plug in negative 5. 1 minus 2 times negative 5 squared. 1 minus 2 times, what is negative 5 quantity squared? 25. And 1 minus 2 times 25 is 50. And 1 minus 50 is a negative 49. Now, those were two pretty easy there, no problems. All right, do next one. And clean it up. This one is f of a plus 4. I don't care what's inside the parentheses. Whatever's inside the parentheses is going to replace the x with the original function. So f of a plus 4 is going to be 1 minus 2 times a plus 4 squared. All I did was replace the x with a plus 4. Now, cleaning it up, that's the big issue. So cleaning this guy up, this would be equal to 1 minus 2 times, I'm going to put a bracket there because I'm going to focus on the a plus 4 squared. Now, a plus 4 squared is a plus 4 times a plus 4. Just writing it to the side over here. And to clean this guy up, I'm going to distribute, FOIL it out, if you will. So FOILing this guy out, a times a is a squared. A times 4 is plus 4a. 4 times a is another 4a. And 4 times 4 is 16. Cleaning that up, that'll be 1 minus 2 times a squared. 4a plus 4a is 8a plus 16. This will be 1 minus, I'm going to distribute the 2. This will be a 1 minus 2a squared. Negative 2 times plus a, 8a is a minus 16a. And negative 2 times a 16 is a minus 32. And the last thing I'm going to do is combine like terms. What is 1 minus 32? So this is equal to negative 2a squared minus 16a. and 1 minus 32 is minus 31. And there is my solution. So far, so good. Again, careless error kills in this class, so you've got to be very adamant in terms of how you're doing your mathematics. And number 2 over here, this is your classic piecewise function. With a piecewise function, you've got multiple pieces of the function, and you just have to figure out which piece of the function you got to plug into, because you only get to plug into one piece of a function. So here, f of x is equal to 2x minus 3 if x is less than 5, negative 4x squared minus 3 if x is greater than or equal to 5. So, we're supposed to calculate f of 5. Well, which piece of my piecewise function do I plug in? Well, f of 5 means x is 5. X being 5, do I plug it into the top one or the bottom? Now, over here is your domain. These are the define of what x's have to be plugged into each part or piece of your piecewise function here. Since x equals 5, and since x is 5, I get to plug it into the bottom one. Does that make sense? So the answer of f of 5 would be negative 4 times 5 squared minus 3. X equals 5, and so which one does that go into? That goes into the bottom. So cleaning this up, this will be negative 4. 5 squared is 25 minus 3. Negative 4 times 25 is negative 100 minus 3. The answer is negative 103. Does that make sense? But, second problem, what about f of negative 3? Well, x here is negative 3. Is negative 3 less than 5, or is it greater than or equal to 5? It's less than 5, so I get to plug it into the top part of my piecewise function. You only get to plug into one piecewise function. So this would be equal to 2 times negative 3 minus 3. Just replace the x, which is negative 3, in the appropriate x function here, which is the 2x minus 3. So 2 times negative 3 minus 3. 2 times negative 3 is negative 6 minus 3. Negative 6 minus 3 is negative 9. Does that make sense? So you don't get to plug into both pieces, and that's what most students will mess up here. You've got to identify with a piecewise function which piece you have to plug into. All right. Domain and ranges and stuff. The definition of a domain in simple terms is the x values you're allowed to plug into a function. Now, let's talk about domain restrictions. Things that you have problems with. Things that you have problems with. Number 1, rule of mathematics. You cannot divide by what number? 0. Can't divide by 0. So dividing by 0 is illegal. Wrong. Can't be done. So therefore, that's a domain problem. I can't divide by 0. When it comes to square roots or even roots, you can't take the square root or an even root of a negative number. You can only take square roots and even roots of positive numbers or 0. Square root of 0 is 0, yeah. But you can't take the square root of a negative number. You can't take an even root of a negative number. Odd roots are fine, but even roots, no even roots of negative numbers. There's a domain problem. Keep going. If you remember your logarithmic stuff, you can't take the log of 0, nor can you take the logarithms of negative numbers. You can only take the log of positive numbers. That was another domain restriction in your past. So when you look at problems, when you're looking at these type of questions, you're looking for problems of the function. So, look at this first guy. Find the domain of the function f of x equals 3x plus 7 divided by 4x squared plus 1. Well, here's the deal. Okay? I can't divide by 0, right? Can't divide by 0. And I have a division problem here. If my question has no problems, the domain is always all row numbers. If I don't see a problem, I can chuck anything into this thing I want to. The answer is all row numbers. But this one, I do have division. So I'm going to have to worry about where the denominator, which is the 4x squared plus 1, when that equals 0. This would be my problem. Now, help me out here. Solve for x. Tell me what x is going to make this bottom 0. So the first thing I would do would be subtract 1. So I get 4x squared is equal to negative 1. Then, get that x squared by himself, I'm going to divide by 4. So I end up getting x squared is equal to negative 1/4. What's the last thing I got to do? What gets rid of squares so I can solve for x's? I'm going to take the square root of both sides. And look what's underneath that square root. Negative 1/4. And we just mentioned this. I can't take the square root of a negative number. So this x does not exist. So remember that's a D, D-N-E. That's my code for does not exist. Which means I'm analyzing where my problem is going to be, but I really have no problem. The bottom will never be 0. And since the bottom will never be 0, you know what your domain is? The domain is all real numbers. Now mathematically, how do we state that with all real numbers? Now the symbol for all real numbers is a double-backed R, but for you guys, we like to discuss domain and ranges and any kind of information about a function in interval notation. In interval notation, all real numbers is parentheses, negative infinity, comma, positive infinity. This is your answer for all real numbers. Negative infinity, I can plug anything into this function and it'll work. I don't have to worry about dividing by 0. However, look at the next guy. Same kind of problem here. F of x equals 3x divided by 2x squared minus 8. Same question, find the domain. Well, again, it's real obvious. My function is a fraction, so I got to worry about dividing by 0. Okay? So, take my denominator, once again, identifying the problem, and that is 2x squared minus 8. I'm going to set it equal to 0. I'm going to find out where my problem is at. So, I've got 2x squared. I'm going to add 8 to both sides. 2x squared equals 8. Then I'm going to divide by 2. And that gives me x squared is equal to 8 divided by 2 is 4. And this guy's positive. So, now, once again, I got to solve for x. I got an x squared. So what am I going to do? I'm going to take the square root of both sides. However, when you introduce a square root into a mathematical problem, square roots have two options. What are my two options? Plus or minus. When you introduce a square root in a problem, you've got to put plus or minus. If I give you a problem that has a square root in it, it's understood to be a positive square root unless I put a minus in front of it. You don't have to worry about putting plus or minus in front of square roots if I give you the square root. But if you, within a problem, have to introduce a square root, you always have to do plus or minus. So, this cancels here, and I get x is equal to plus or minus the square root of 4, which means x equals plus or minus square root of 4 is 2. These are my problem points, which means x cannot be equal to 2, and x cannot be equal to negative 2. These are my two problem points. But as I mentioned to you guys before, traditionally, we want to see this in interval notation when they ask you for the domain. So in interval notation, I'm just going to draw a number line just to give you a visual representation of what's going on here. This is your number line. Here's negative infinity, here's infinity. My problem points were at negative 2 and at 2. We need to omit them. To omit them, we'll put open circles around them. That means I'm going to exclude. So I can have any kind of number I want to except for negative 2 and positive 2, which means the domain is going to be negative infinity to negative 2, but to exclude something or other, you put a parenthesis. To include it, we use a bracket. And then I'm going to put a little union symbol here, pick it up again, negative 2 to 2, parentheses around that because I got to omit negative 2 and 2, another union symbol, and then pick it up the rest of the way, 2 to infinity. This is an interval notation, what the domain is. Now, Hawks will accept either one of these answers right from the beginning, but I'm going to go ahead and forewarn you, we're really after these interval notations, so get used to writing this stuff in interval notation, okay? If you'll notice what I'm doing here is I'm cranking up the heat on this thing. I'm doing different kind of problems in terms of algebra review. So yeah, I'm just trying to scare you guys. So here we go. So number 5 here. Find the domain of the function f of x equals 2x plus 1 over x squared minus 7x plus 10. All right. Well, again, It's a big old fraction. When it comes to fractions, my problem is when the denominator equals 0. So I'm going to identify the denominator, x squared minus 7x plus 10, and I'm going to figure out where my problem is at. So I'm going to set it equal to 0. So the problem is, again, the denominator equaling 0. Now, this is, look at it, x squared, you can barely see my square there, but here it is, x squared minus 7x plus 10 equals 0. It's a quadratic equals 0. You guys remember how to solve this thing? What are you going to do? Factor it out. What times what is x squared? It's x and x. What times what is 10? That when I multiply, I'm going to get 7 now. And because it's plus 10, I got to have two factors that I multiply together to give me 10 that add up to be 7. Since this is a plus, I have to add it to be the middle term. What are my options here? What is that? You got it, 2 and 5. And they're going to but. What signs do they have to have? Now you're adding them up, but since the middle term is negative, that tells you both of these two guys have to be negative. And if you don't trust me, FOIL it back out again and see if you don't get back to the same problem you got. Okay? Now, here's the beauty of this concept of factoring. We have this algebraic property that if two things multiplied together equal 0, that implies that either the first guy, x minus 2 factor, is equal to 0, or the second guy, x minus 5 equals 0. Solving for x equals 2, or x equals 5. These are my two problem points. So in terms of the domain, which is what we're after here, x can't be 2, because that would make me divide by 0. And x can't be 5. Okay? However, to write this in interval notation, you can first write it as a number line again if you want to see it. So I've got to omit 2, and I've got to omit 5. So negative infinity to infinity. So interval notation would be everybody but 2 and 5. So this would be negative infinity to 2, union 2 to 5, union 5 to infinity. Now, I'm just trying to give you a visual aid, but honestly, you should have the ability to go from the x can't be 2, x can't be 5, to negative infinity to 2, union 2 to 5, union 5 to infinity. Then I throw another one at you. Find the domain of the function f of x equals the square root of 2x plus 3. Now, square roots have a special type of restriction. You can't take the square root of a negative number, right? Which means you can only take the square root of positive numbers or 0. So here's how you handle a square root in terms of domain. Because with the domain restriction, the restriction is what's underneath the radical, which in this case is the 2x plus 3, has to be strictly greater than or equal to 0. You can only take the square root of 0 or positive number, greater than or equal to 0. So this gives you, now you got to solve for inequalities here, but pretty much you get the x by himself. The only deal you have to worry about inequalities, if you remember, is if you multiply or divide by a negative number, what do you got to do? Switch the sign. So we're reminding you of the algebra that you did before you got in this class. So I'm going to solve for x over here. So I'm going to subtract 3 from both sides. And this is going to give me 2x is greater than or equal to negative 3. And then I'm going to divide by 2 on both sides, getting the x by himself. So x is a positive 2, so no sign change. X is greater than or equal to negative 3 halves. And you can state that as your domain. X has to be greater than or equal to negative 3 halves. But I want you guys to get used to the interval notation. Now, greater than or equal to 3 halves, just to give you a visual here, here is 0 right here. Here is your negative 3 halves. It's got to be greater than, so anything over here on the right, but equal to means we want to include, and a filled-in dot means include. In terms of interval notation, to include, we use the famous bracket. Bracket, negative 3 halves to infinity. That is the interval notation. And again, Hawk system will take it either way. I mean, you can put it either way. But I'm setting you guys up for my test because traditionally in calculus, we're going to do things in interval notation. So get used to that. Now, I'm trying to throw some curveballs at you here. Here it is. Find the domain of the piecewise function. F of x is equal to, and this is how you would read it, f of x is equal to negative 2x squared plus 1 if 0 is less than x, which is less than or equal to 7, and 3x minus 6 if x is greater than 7. Okay? Now, this is what we're talking about here is what is the domain of a piecewise function? And that's basically the question here. The domain of a piecewise function. Domain of piecewise function is this stuff right here. The two pieces that tell you what you're going to plug in. And so what we're talking about here in terms of domain is 0 is less than x, which is less or equal to 7, and x is greater than 7. That's my domain. So if you want to sit there and look at that in terms of a number line, 0, we're going to, it's not equal to, so it's open circle on 0 all the way up to 7. We're going to include 7, and then we got x is greater than 7, so we're going to pick stuff up after 7. Now, if you put these two concepts together, 0 is less than x, which is less or equal to 7, union or and, x is greater than 7. Okay? What have I got? That means x has actually got to be greater than 0, if you think about it. Because it's 7, you hit it on this one, and then you pick it up the rest of the way after 7 here. So you got both of them. You got 7 and stuff greater than 7, because equal to here and then greater than here. So in interval notation, this is just going to be parentheses 0. Again, halt. We'll take it either way. Don't put the word or. You get to decide which way you want to type it in, but there you go. Does that make sense? So piecewise functions are real nice because we kind of throw it in your face what the domain is, but you have to interpret. You got to put the two pieces here back together again to see what kind of x's you're chunking into this guy. Questions, complaints, comments? Now, what you're supposed to do is just make sure you understood all this good stuff. When you go over here to 6.8 on Hawks, you're supposed to do some practicing. But I know what most of you people are going to do. You're going to go over here because there's no points where if you mess up, you can always take it later. You can do it again. That's true until the cutoff date. And then you're going to go over here and certify. But the goal is to make sure you get the certified questions here. So I'm just going to show you one. Let's do the certify. Are you working for me? Come on. Hello. Ah, there we go. There are 13 questions on this one. And here, they even try to mess you up with this one. So let's do this one together. Okay? What is the domain for this guy? They put two things together. So I've got some scraps of paper over here. So I just want to show you. All right? This is why you want to do that practice stuff, because they'll do even more problems under your practice section and stuff. So here we go. F of x is equal to 3 divided by the square root of 4x plus 6. Okay, and again, the question is, what's the domain? So I'm going to quickly click back over here, and it should just show you this particular problem here, and I'll make it full screen so everybody can see it. There it is. All right. What's the domain? All right, you got two problems here. And so you got to do mathematics in your head. Two problems is this. My problem is, okay, can't divide by 0. That's one problem. And the second problem is, because you've got a square root, is can't take square root of a negative. That's a problem. And so this was kind of a combination of both of them. You with me? So, I got to put those two concepts together. Now, in terms of this, the square root of 4x plus 6 can't be equal to 0, and just underneath the square root can't be negative. So the 4x plus 6 has got to be greater than or equal to 0, because what's underneath the radical must be greater than or equal to 0. So again, I'm tying these two concepts together. Now on this guy here, I don't like square roots. And if I look at this guy as an equation, I can get rid of a square root. How do you get rid of a square root? Square both sides. So I'm going to literally square both sides on this one. So this will give me the 4x plus 6 can't be equal to 0 squared. But what's 0 squared? 0. So I just got rid of the square root by squaring both sides. So I've got this. The 4x plus 6 can't be 0, and 4x plus 6 has got to be greater than or equal to 0. So if you've got to be greater than or equal to 0, but you can't be 0, this will imply that the 4x plus 6 has got to be strictly greater than 0. It can't be 0 because that would make you divide by 0. So the 4x plus 6 has to be greater than 0 so you can take the square root of it. Does that make sense? Now, go solve this thing. I'm going to subtract 6 from both sides. I get 4x is greater than negative 6. I'm going to divide by 4, reducing my fractions. X has got to be greater than negative 3/2. There's my answer. In interval notation, that would be parenthesis negative 3/2 to infinity. Does that make sense? Got to be bigger than 3/2, and not including negative 3/2. Got to be greater than negative 3/2. So over here, let me do this thing, and come back over here. And so I'm going to type this thing in interval notation, and I can use my little keypad punch thing here, but you guys are the experts on all this stuff. And actually, I can just start with the parenthesis here, so I'm going to X out of this thing real quick. Only when I want to use fractions and stuff. The keypad is very helpful here. But the answer is going to be parentheses, right? Negative 3/2. I'm going to use the old keypad for typing in the fraction. So where's my little fraction button? Right here. So what is this? Negative 3/2. Come over here and put the little comma. And then what do I want? Infinity. Where's that sucker at? Okay, up there it is right there. Okay, and I'm going to X out of it. And then I'm going to submit my answer, and I'm going to hear, oh, you got it. Hey, that's what I want. UNC Charlotte Green at the bottom of it. Does that make sense? And you've got to do this 13 more times, so I got 1 out of 13. So there you go. Does that make sense? Have I lost you guys anywhere? All right, let's take a look at, real quick, section 1.6 over here, the next section. Okay, and that is the operational function. Now, officially, I was supposed to do 1.6a and 1.6b, but because of the starting semester, don't worry, we'll get ourselves called back up. But I probably won't finish this one today. But here we go. This particular one, this is going to be dealing with basically composition of functions and putting them together and taking them apart again. So again, in terms of this stuff, to kind of set you up, this idea of composition, we're putting functions together to make more functions. That's what this section is all about. So in terms of your learn mode here, very quickly, you know, what is that little circle, f, you read it, f of g of x. What does that actually mean? That really means that's equal to f of g of x. In English, you're going to plug the g of x function into the x of f of x to create a whole new function called composition functions. Plugging one function into the x of another function, okay, to create bigger and better functions here, okay? In terms of how this stuff works, this composition, f of g of x is not equal to g of f. They're not going to be equal to. And let me write that in English. F of g does not equal g of f typically. There's a few examples I can make up that, hey, they work, but if I just made up crap off the top of my head, f of g is not going to be equal to g of f. Okay. Okay. When we talked a little bit about this last time, what does delta x stand for? Change in x. So in terms of change in x, what you're talking about here is change in x. Like I said, x2 minus x1, the difference of x's. This is, like you said, change of x, okay? And what do you think delta y is going to be? That will be the change in y, right? So what more formula would that be? y2 minus y1. So, in other words, remember that slope thing we did last time? The formula for slope you've got memorized. y2 minus y1 over x2 minus x1 is equal to the change in y over the change in x. But we are talking about this being functions. So y2 would be f of x2 minus y1 f of x1 over x2 minus x1. There's another way I could write this thing. Okay? So this idea of composition and stuff here. And just because the Hawks video thing that I want to do very quickly before you guys leave now, what symbol is that right there? In this problem right here, I got f of x equals the square root of x plus 2, and g of x equals x divided by 5 divided by x. What is that? Is that an open circle? No, it's a dot. In algebra, what does a dot stand for? Multiply. So what is f of x times g of x? That is very simply equal to the square root of x plus 2 times 5 over x. Now you can clean that up and make it look good. That would be 5 times the square root of x plus 2 divided by x. Look, we've taken two different functions, chunked them together, and made a new function out of it. That's what this section's all about. Does that make sense? Now this guy here, g of f of x. It would also be written g of f of x like this, but g of f of x. Now what you're supposed to do is plug one function into the x of another function. It's basically inside, outside. That's what we're focusing on. G is on the outside. G is your commander. He's the guy in charge. What does G look like? G of x looks like 5 over x. So it's going to look like 5 over, instead of x, we're going to put in that f of x function, replacing the f with what's on the inside. Now what is f of x? That's 5 over f of x is that square root of x plus 2. So if you look at this guy, what you really did was you looked at the g function, he was in charge, so it's going to look like this. You replace the x with the actual f of x function. This is what g of f of x is. Putting one function into the x of another function, okay? But we'll do more of these problems next time for you guys. We'll finish up section 1.6 and then continue on. And don't worry, we'll get ourselves caught back up and stuff like that. But the big thing is go ahead and get your access codes and get the book and get working on this stuff. And I'll see you guys on Monday.